Section 8.9, Electric Circuits. So anytime that we have a path through which electrons can flow due to a potential difference, so a voltage, we call that a circuit. In order for a circuit to work, it has to be continuous. So it has to be complete. There has to be a starting point and ending point. All those points need to be connected. This is because you don't have so much electrons traveling on one single path, but you're nudging each one along down through the wire. So if there's a break in the wire, then the nudging stops and the signal stops traveling. Now there are two basic types of circuit connections, and most circuits that are built off of these general ideas. Now some can be extremely complex beyond this, but just two basic ways that you can connect things. The first is what's known as a series circuit. In a series circuit, everything's connected in a straight line. So you start from the battery, and from the battery, everything's connected in a straight line all the way back to the battery. If you take out one of these circuit components or one of these circuit components break, the circuit is not complete and it doesn't work anymore. So older Christmas lights and strings of lights and things like that are sometimes made in series so that if one bulb goes out, the rest of the bulbs go out and you cannot determine which one works and which one doesn't. In a series circuit, because everything's in one straight line, the current through all parts of the circuit is the same. There's just one set of electrons being nudged, and so the same amount of current is occurring through this wire at all times. The second way you can connect objects is what's known as a parallel circuit. In a parallel circuit, you have multiple components connected to the battery essentially at the same time. So we have this component connected to the battery, but we also have this component connected to the battery. And so there are two separate paths. There are separate paths for the electrons to take. There's separate paths for them to be nudged along. Because of that, the potential difference across each of these circuits is the same, but the current won't necessarily be the same. The only way the current is the same in both of these is if you have the exact same light bulbs. The parallel circuits are beneficial because if you remove one of the components, the other one will still work. And so this is how strings of lights are built now. They're all connected in parallel so that if you lose one light, the rest of the other lights will stay on. You can figure out which ones are working and which ones aren't.